This project was a large-scale operation to extract gold from a massive haul of vintage electronics. Driven by the fact that older devices contain significantly thicker and more generous gold plating compared to modern, cost-optimized devices like a MacBook, gold is used in electronics for three key technical reasons. Its superior corrosion resistance, it doesn't oxidize. Its excellent electrical conductivity, minimizing signal loss, and its durability withstanding repeated physical connections. The sourcing mission began at a flea market, hunting through stalls of junk. Valuable finds included an old desktop computer with a CRT monitor, piles of greenies circuit boards from old TVs and VCRs, random radio parts with gold connectors, and classic mobile phones with retractable antennas. Online classifieds supplemented the haul, though many sellers were already aware of the refining potential. The final inventory was substantial. 4.6 cache of old Hixons, a diversos aos medicamentos, 10 kilograms of green boards, 2 kilograms of loose chips, 2 boxes of vintage phones, 30 kilograms of motherboards, a collection of CPUs including ceramic ones, and a bag of mixed radio parts. The first labor-intensive phase was material preparation. Working in a garage generated toxic smoke from burning fiberglass, forcing a relocation to a remote wooded area. Using torches, the team desoldered valuable components, chipsets and gold-plated connectors from motherboards, microchips from green boards, and memory chips from RAM sticks. The phones, including models like the Nokia 3310, were disassembled, revealing gold under keypads and within their circuitry. All materials were sorted into 6 categories for different chemical treatments: phone boards, processors, RAM contact fingers, chips, old ICS and gold-plated connectors. The chemical extraction employed 2 main methods. For the chips and ICS, where gold is embedded inside, a multi-step process was used. First, the components were treated with a hot acid mix to dissolve the metal legs. Then, the plastic was burned off in a fierce bonfire. The resulting material was ground into a fine powder and burned again. This ash was treated with nitric acid to dissolve base metal impurities, then filtered. The gold was dissolved from the remaining solids using aqua regia, a mix of nitric and hydrochloric acid. The gold was then precipitated from this solution, dried, and melted. The yield from this category was 0.2 for 2 grams from standard chips, but a second batch containing RAM and motherboard chipsets yielded a surprising 2.7 grams. For components with exposed gold plating connectors, processors, RAM fingers, phone boards, a chemical stripping method was used to avoid dissolving the bulk metal. The components were submerged in a Gentian reagent solution for about 24 hours. A nervous overnight wait ensued due to the risk of the gold replating onto other metals. The next day, the gold had successfully dissolved into the solution. The stripped components were discarded, and the gold-bearing solutions were filtered through a large DIY filtration system made from a glass carpet. The gold was recovered from these solutions through cementation, stirring in zinc powder, which causes the gold to chemically swap places and stick to the zinc. This zinc gold sludge was treated with nitric acid to dissolve the zinc, leaving behind gold powder. This powder was then dissolved in aqua regia, precipitated, and melted into beads. The yields from each category were: processors, CPUs, 3 grams, phone boards, 4.36 grams, connectors, 1.16 grams, RAM modules, 1.78 grams. The grand total exceeded 13 grams of recovered gold. While it could not be sold legally on the official market, it was sold on a gray market for $1,384, slightly below the spot price of $1,520, but a substantial return. The video concluded by showcasing the physical cost of the endeavor: acid-burned clothing, ruined equipment, and chemical-damaged work surfaces, highlighting the chaotic, dangerous, but ultimately profitable nature of extracting precious metals from e-waste.